Alright, welcome to Lesson 19's checkpoint. We're just going to start with question 1 since it is a proof. Use the following proof to answer the question. Given AD divided by BD is equal to the portion of AE divided by EC, prove that segment DE is parallel to segment BC. Alright, so in this, they're just stating that this side length, AD, divided by this side length is going to equal the same number as AE's side length to EC's side length. So their ratios are the same, or proportion. Now we're going to assume that segment DE and segment BC are not parallel. Then there must be another line that is parallel to segment BC. Take a point F on the side of AC, so we can apply the blank, and then AD divided by DB is equal to AF divided by AC. So they're saying that there's going to be some other point here, F, and that point is going to since we created it to be parallel to BC, then we can just say we could draw it. I know it's not drawn accurately, but they're saying just that from D to F would be parallel to this point. And so we can apply the triangle proportionality theorem. If it is parallel, that means that from A to D segment divided by DB, it means it splits those sides proportionally. And then would be equal from A to F and F to C. So that's what the triangle proportionality theorem is. I think of it as a ladder. If you look sideways at a ladder, it has rows and the steps are parallel, and each of these are proportionate. So this is proportionate to this portion, and it would have to be the same proportion from here to here. So, for example, if you had a ladder that only had 3 steps, and you set it up like this, the sections on each of these side lengths would still be proportional to each other. So no matter how you set up that ladder, this portion divided by this portion would give you the same number as this portion is to this portion. So I remember it as a ladder. So blank 1 is going to be our triangle proportionality theorem because it's stating that there has to be another line that is parallel. And then it's giving us the ratios of the sides that it's splitting. So using AD divided by BD is equal to AE divided by EC, we can have AE divided by EC equal to AF divided by FC. And that is coming from this statement right here is coming from what is given. And then the AE equaling AF divided by FC is coming from the transitive property because they have AD divided by DB right here. and it's also right here. So here's our linking man, that middle man. So then we have AE divided by EC. We skipped our middle man. It's going to equal AF divided by FC. So that's how they came up with this ratio equality. Next, we add 1 to both sides. That's the addition property of equality, which means what you add to one side, you have to add to the other in order to keep both sides equal. So you can do that. So AE divided by EC plus 1 is equal to AF divided by FC plus 1. If we replace the 1's with EC divided by EC and FC divided by FC, why can we do that? Because any number divided by itself is equal to 1. So this 1 could also be rewritten as 3 divided by 3 or 10 divided by 10. And since EC is talking about a length, which is a number, we just don't know it. It's just represented by EC, and it's dividing it by that same number. It is a form of 1. And add the fractions. We get AE plus EC divided by EC is equal to AF plus FC divided by FC. And the reason why they changed this one to EC divided by EC is so that they could have a common denominator, which you have to have in order to add fractions, and the denominator right here was given as EC. So then on the right side of the equality, since the denominator in this ratio is FC, they used FC divided by FC to replace this one right here so that they could add those fractions together. Thus, blank. That equality gives us that segment EC equals segment FC. So now if we are looking, we would have that AC divided by EC, so or AB divided by EC. Those are our options. So A to C is right here, and that's our segment addition. What is AC made up of? AC is made up from A to E and E to C. So right here, A to E plus E to C makes up the segment, makes up our segment plus AF. Remember by definition where it told us that it was on the side of AC, so it was also somewhere over here. And again, it's some segment addition. It's the segment addition that A to F, from A to F plus F to C is going to give us this total length. So that is also AC. So in step 2, it's AC divided by EC is equal to AC divided by FC. That equality gives us that segment EC is equal to segment F. That is because since AC is in our numerator on both sides of our equality, the only way, so for example, if AC was equal to the length of 1, I would have 1 over something. Now EC has, whatever this denominator right here is, has to make this true. So if this is a 2, I can't put a 4 here. FC couldn't be 4 because 1/2 does not equal 1/4. So it has to be 2. So 1/2 equals 1/2. That means that EC right here has to equal FC. And we can see that E and blank coincide. That means that segment DF must coincide with segment DE. Since we assumed that segment DF is parallel to segment BC, then we have segment DE is parallel to segment BC. So we had right here, coincide means it has to be in the same place. Since segment from E to C and F to C has to be the same distance. That means point F and point E have to be at the same place. That's what coincide means. It means it's at the same place. This means that segment DF must coincide with segment DE, or it has to be the same line. Since we assumed that segment DF was parallel to segment BC, then we have segment DE is parallel to segment BC because DF and DE are the same line, or since they coincide. So our blank 3 is F. So there's our first proof. Use the following proof to answer the question. This one is extremely similar to question 1. So I will let you use your power of observation and compare question 1's proof to question 2's and fill in the blanks. Alright, question 3. DE is parallel to GH, which is parallel to AC in the following figure. Also, BE is equal to 12 units, B to D is equal to 16 units, G to A is equal to 4 units, and E to C is equal to 9 units. What is the correct way to set up the proportions to solve for DA? Select the reasoning behind your proportions. Okay, since we are given that we have parallel lines within this triangle, we have the triangle proportionality theorem because it was given parallel lines and we're ending with proportions. The converse is starting with proportions and ending with parallel lines. So I do know that it is the triangle proportionality theorem because we were given parallel lines first. And now we have to set up for DA. So segment DA is the segment that is cut off between the parallel lines DE and the parallel line CA. And so on this side leg of the triangle, I can go from B to D and D to A. So DA, since that's a missing piece that we want, I'm going to keep it in the numerator. It's going to be proportionate to DB or DD. And that's going to equal the same proportion as the length on the other side. So for side B to C, DA's corresponding portion would be E to C divided by B to E, because that's the corresponding portion for D to B. So B to E. And by substitution, we are going to have DA, which we do not know, DA, and DB's length, or BD's length, is 16 units, is going to equal E to C is 9, and B to E is 12. So we're going to set up our proportions like that. And right now I'm scanning this. And I'm noticing this first one, A, 12 divided by 9 is equal to 16 over DA. That is the exact reciprocals of what we have set up, which can also be used. They just, instead of putting the DA in the numerator, they put it in the denominator. So that reciprocal, since 9 divided by 12 is the reciprocal of 12 divided by 9, and dA divided by 16 is also equal to its reciprocal. That is our statement for our proportions. They just set it up. Instead, they said that dB was proportionate to dA, and that's going to equal dE being proportionate to EC. So it is the reciprocal of the proportions we set up, which is correct. All right, question 4. Consider the following triangle. What is the length of segment BC? Justify your answer. Noticing first in triangle ABC that we have a 90-degree angle marked here. That means that we could use the Pythagorean theorem to find our side length. Pythagorean theorem can only be used in right triangles. The Pythagorean theorem is side length, so AC squared plus the other side length, BC squared, is equal to the hypotenuse squared, so AB squared. By substitution, AC's length is 3, so I have 3 squared plus BC squared. The length of BC squared is equal to, the length of AB is 5, so I have 5 squared. Alright, now 3 squared is 9, plus the length of BC squared is equal to 5 squared is 25. Using our subtraction property of equality, I'm going to subtract 9 from both sides. So 9 minus 9 is 0, plus the length of BC squared is equal to 25 minus 9 is going to give us 16. So 0 plus the length of BC squared is BC squared. So BC squared equals 16. Now, the inverse operation of a square is a square root. So we square root both sides. So we have the length of, the square root of BC squared is BC, is equal to the square root of 16 is 4. So the length of BC is 4. Alright, so now I'm going to tell you from The Little Book of Calm by Paul Wilson again. Your advice for bringing calmness into your life is to seek the best in everything. Make a practice of looking for the best in people and situations. You'll find that simple